Good morning, students. Today we are going to start with Green's theorem. First of all, the statement of the theorem is if m of xy and n of xy are the two continuous functions of variables x and y which are having partial derivatives curly m by curly y and curly n by curly x in a region R which is bounded by a closed curve C, then the line integral along a closed curve C m dx plus n dy is always equal to the surface integral bounded by the region R curly n by curly x minus curly m by curly y into dx and dy. So this is the statement of the theorem. Basically, Green's theorem deals with a line integral with a surface integral. Okay, and now we are going to study about the questions related to it. Now we have a question. Using Green's theorem, we have to evaluate line integral along a closed curve C, y minus sine of x dx and cos of x dy, where C is the plane triangle enclosed by the lines x equal to pi by 2, y equal to 0 and y is equal to 2 by pi into x. So these are the three coordinates or three lines which we are going to deal. First of all, what is the given statement? They have given that along the curve C, y minus of sine of x into dx plus cos of x into dy. If I compare it with along the curve C, m dx plus n dy, so the value over here is y minus of sine of x, that is a value of m, and the value of n will be cos of x. Okay, so they have mentioned that we have to use Green's theorem. So by definition of Green's theorem, line integral along the curve C, m dx plus n dy is equal to surface integral bounded by the region R curly n by curly x minus curly m by curly y into dx and dy. That means we are requiring curly n by curly x and curly m by curly y. So from this part we differentiate curly m by curly y. Now derivative of y will be 1 and derivative of sin x will be 0. So the result will be 1 and curly n by curly x. So derivative of cos x will be minus of sin of x. So that means curly n by curly x minus curly m by curly y is equal to minus of sin of x minus of 1. So if I take negative sign common, so it will be 1 plus sin of x. Okay, now about the double integral. For double integral we need the area. Now we have given three lines, x equal to pi by 2, y equal to 0 and y is equal to 2 by pi x. Now we have to find the limits. So for finding the limits, first of all we plot the diagram. So here what we have been given. So this is our x-axis and y-axis. This is x, y, and this is our region. So first of all, the given points are x is equal to pi by 2. So when x is equal to pi by 2, y will be 0. So this is the coordinate x equal to pi by 2 and y equal to 0. The second is y equal to 0. Y equal to 0, that means the x-axis, this one. Okay. And the third one is y is equal to 2 upon pi into x. That is some line passing through the origin. Okay. So this was your line x is equal to pi by 2. This is your line y is equal to 2 upon pi into x. Now we are not aware about this point of intersection. So first of all we need to find the point of intersection. So to find point of intersection of section, what we are now, look here, x is equal to pi by 2 and here y is equal to 2 upon pi of x. So I substitute the value of x equal to pi by 2 over here. So y is equal to 2 upon pi into pi by 2. So 2 and 2 cancel, pi and pi cancel, so value is 1. So that means the point of intersection is pi by 2 and 1. Now we have to find the limits. To find the limits, let us suppose we have a vertical strip. This is your vertical strip P and Q. So at point P, so the value of y will be 0, and at point Q, the value of y is, at this point the value of y is 2 pi by x. So 2 by pi into x, sorry. Okay, so that means the variation of the region R is xy, that is the coordinate system. Now x is varying from 0 to, this is point A, 0 to A, that is pi by 2. So x is varying from 0 to pi by 2 and y is varying from 0 to 2 over pi into x. Okay, so these are the limits. Now substituting all the values in equation 1. So line integral along the curve C, y minus of sine of x into dx plus cos of x into dy is equal to surface integral of minus 1 plus sine of x. Now we have two variables x and y. So the variable which is having dependent limits is to be kept inside, 0 to 2 upon pi into x dy, and the variable which has constant limits is to be kept outside into dx. So that means we are going to integrate first of all with respect to y, taking minus as constant, so outside, so 0 to pi by 2. Now 1 plus of sin x is dependent upon x, so that means it is a constant, and integration of dy with respect to y will be y 0 to 2 upon pi into x dx. That means upper limit minus lower limit, so 2 upon pi x minus of 0 into d of x. Now out of this 2 upon pi is constant, so I am taking it outside, 0 to pi by 2. Now this x into the bracket, so it will be x plus sine of x into d of x. Now I have to integrate with respect to x. Now integral of x will be x square by 2 plus, now here we have 1x, so this is your u and this is your v. So first function as it is, integral of second, so minus of cos of x minus derivative of x will be 1 and integration of this one will be minus of sine of x within the limit 0 to pi by 2. So minus 2 upon pi x square by 2 plus minus minus x cos of x minus minus plus sine of x 0 to pi by 2. Now upper limit minus lower limit, so pi by 2 whole square by 2 minus of pi by 2 into cos of pi by 2 plus sine of pi by 2 minus lower limit 0. 0 over here is 0. 0 into something, that will be 0, and sine 0 is 0. So minus 2 upon pi, so pi square will be, and 2 square will be 4, 4 2s are 8, minus pi by 2 cos 90 is 0, 0 into something 0, plus sin 90 is 1, so value comes out to be minus 2 upon pi into pi square by 8 plus 1. If you want to open the bracket, so it will be, I'll expand it, 2 upon pi into pi square by 8 plus 2 upon pi. So 2 1s are 2 4s, right? 1 pi and pi cancel out, so I get minus pi by 4 plus 2 upon pi, and this is your answer.